In this video, I'll go over a few example capacitors. I talked about this in an earlier video. This one here is what we call the Leyden jar. It is made up of a conducting shell on the outside, and then this is glass, an insulator. So we have the metal, then glass, and we have here a chain. What we do, we put the charge, a negative charge or positive charge here. In this particular case, it's negative. And we put the positive charge here, in the metal here, in the copper. That's the early capacitor, where people started investigating what capacitors are and how to collect charges in capacitors, etc. This one here is a parallel plate capacitor, like the one used in lab. We connect an electrical wire to this end, another electrical wire to this end, and we'll have a positive and negative charges here, and we can change the capacitance by changing the separation of the plates. Now, commercially, capacitors might look like this. These are large capacitors. These are in the microfarad range, what we call electrolytic capacitors. Even this is most probably electrolytic, this one and this one, kind of smaller version of these big ones. And then we have other capacitors. These, we call them ceramic capacitors. These are in the picofarad, the ceramic capacitors. The others are more in the microfarad. For example, this one, the value is written here. It is 8,000 microfarad. This is quite a large capacitor. Okay. Now, other examples of capacitors. There are some very tiny ones. So if you essentially see the inside of a laptop or a phone, a lot of the capacitors are going to be like this or even tinier than this. Look at this is in millimeters. This is a ruler. This is an electrolytic capacitor, 2.2 microfarad. Now, I'm not sure what kind of capacitors are these, but they are small capacitors. This is ceramic. This is also ceramic. And then you have some other types of capacitors, like this one. I don't know exactly what it is. This is another version of the parallel plate capacitor that you used in lab, but it's a variable parallel plate capacitor. You can rotate this rod here, and by rotating it, these plates are going to rotate. So the overlap between the plates is going to change. By changing the overall overlap, we change the capacitance. That's what makes it a variable capacitor. This kind of capacitor is what was used for tuning radios in the past, and maybe even TVs.